Okay, hello and welcome everyone. I'm Sarah, I'm from the Green Register, and thank you for joining us tonight at our Twilight Talk, Design for Manufacture and Assemblies, DfMA. In a moment, I'll be handing over to Deo, but before I do that, I just want to outline a few housekeeping items. So microphones, if you keep them turned off while the speaker is speaking, just so we don't pick up any background noise or anything else from your microphone, just because it can be so distracting. Videos, feel free to leave it on or off, completely up to you. Sometimes it's nice for the speakers to be able to see who's listening, but totally personal choice. There'll be some period at the end for question and answers. So if you've got a question, pop it in the chat box as we're going through, and we'll go through those at the end of the presentation. Technical issues, if you do have any technical issues throughout the session, then send me a message in the chat and a private one, and I'll do what I can to help. Sometimes if it's a connection issue, turning your camera off can help the connection, but anything else, just give me a shout and I'll do what I can. At the end of the session, we will be sending out a feedback form. I know you get feedback forms for absolutely everything these days, but it's really helpful for us to know what you enjoyed, what you'd like to see more of. So please do consider filling that out and letting us know what you think of the session. We'll also be sending out the speaker presentation and a copy of this video. So you'll get that, and also the chat transcript as well. So that's everything from me, and I will hand over to Deo. Take it away.
Hi everyone, what a great turnout. Thank you very much for having me. I will now attempt to share my screen and we'll make a start with the presentation. So can you already see my screen? Yeah.
Yeah, it's loading now.
Super.
Yeah.
Am I good to go?
Yeah, good to go.
Super. As I said, thanks for the lovely introduction. As I said, I'm trying to, with a very broad brush, really give a kind of very succinct presentation about mass timber buildings and how we at Eurban use what we call design for manufacture and assembly techniques to sort of optimize our processes. So first and foremost, I'm Adedayo Shittu-Balogun. I'm the Director of Projects here at Eurban, and my background is actually in architecture. I'm a qualified architect. I worked as an architect for many, many years, just over a decade before I sort of moved over to Eurban to run the project management team at Eurban. So I now look after that project management team, which is one of sort of 3 or 4 teams we have at Eurban, sort of loosely arranged. So as we all know, the concept of modern methods of construction or mass timber or DfMA, all of this has been around for a very long time. And now I think none of this is new to any of us. And, collectively, what we're trying to do as an industry is design and construct sustainable buildings. Evidently, we all have global targets to meet, but also minimize waste in the process and mitigate risk and ultimately create cost-efficient solutions whilst we're in the process, because the bottom line has to stack up in the end. So at Eurban, this is what we've been doing for 20 years. This is actually our 20th year in operation, was marked by a minor celebration at the end of April. So April 28th, we were 20 years old. So we've been at this for a while, and we've learned lots of lessons along the way, hopefully some of which we can share with you today. Right, so as I said, we've been doing this for quite a while. I only joined Eurban about 6.5, nearly 7 years ago. So my presentation is going to basically tell you who we are as a company and what we do, a bit about our experience over those 20 years, and shed some light on our approach, which is ultimately underpinned and has been from the very beginning in a very sort of DfMA-led agenda. We use DfMA, roughly or loosely speaking, to optimize our processes whilst we're designing our lovely mass timber buildings, but also we are constantly looking for ways to improve our workflow. And then I'll use a couple of case studies to just to illustrate the points that I'm trying to make, really. So we've been around for 20 years. We've delivered something like 350 buildings in the UK. Having said that, we do work globally. So we've seen lots of buildings on site in and around the world as well. We have an office actually that operates out of Switzerland. We have essentially, we're sector diverse. We operate and historically have operated a sort of design to site infrastructure. Excuse me. And we're very much leader in our space in terms of design in the digital sense. Excuse me. And BIM, generally or loosely speaking. So ultimately, beyond the structure, what we're doing as committed as a group of people is just trying to really deliver more efficient and sustainable buildings. Excuse me. So as I said, we are operating out of 2 offices at the moment. One is in Switzerland, where one of the directors comes from, and we're a group of timber engineers. As I said, I'm an architect myself, project designers who come from a varied number of backgrounds, architectural technology, architecture in itself, and then a group of project managers, and then we have a couple of people who look after the construction management side of our business. So we basically run the end-to-end process. We have the benefit of having this sort of panoramic view on the process, and it means we do everything from design engineering. We independently source material, so we don't necessarily manufacture ourselves, but we're able to sort of go to market for the most competitive product, for the best project, and we assemble the buildings, and that's how we've sort of come to where we are 20 years on, basically. So we started out from a very, very tiny scale building, and now we're delivering really a range of projects in a number of sectors across the board. Any shape, building size. We've done a residential, private residential development, small interventions, not necessarily buildings per se, interventions, and then we've delivered some quite sort of voluminous in terms of timber buildings as well over time. So as I said, our heritage is in design, supply, and install. So we run this like idea of, the whole idea of the golden thread, kind of, it's a constant learning loop for us. We've done this in a number of ways over and over and over the 20 years. And we have the benefit of being able to see the panoramic process, and therefore we're constantly learning as an organization. Really. I'm now going to go into a bit more about, what we do in terms of DfMA and design for manufacture, and how that helps optimize our processes, really. So what we do really is, optimization is one thing, but and that underpins everything that we do. But what we do really is try and overlay our processes on top of industry standards and what everybody knows to be industry standards in terms of, the RIBA stages of work. So this is a very sketchy concept that our BIM manager came up with a number of years back. And the idea is just that, we're able to sort of plug in at any point in time. So anything running from the strategic brief definition from an RIBA job stage point of view, right to the end, we're able to sort of develop our processes to slot in to any point in time in this sort of matrix of RIBA stages. And over, we've gone around that loop. On some projects, we never get involved beyond stage 4. Some projects are just seeking our input and our expertise and our knowledge in the earlier stages. Some projects where we're trying to define a brief, for example, as to whether mass timber as an option is even viable at all. So sometimes we come in when, seams are optioneering, and other times we come in as a specialist subcontractor to actually, they finished optioneering, they've determined that mass timber is the way forward, and then they're trying to deliver their buildings in mass timber, essentially. And really our deliverables, depending on where we plug into the process, really depends on what the team needs from us, and also what stage the job is at. So, initially sort of feasibility stage, RIBA stages 1, 2, 3, we develop concept models, we produce cost estimates, we try and understand actually in terms of rough principles and rough sort of engineering strategy, what might a mass timber building look like. We develop options and ultimately eliminate, through an elimination process, work out what best suits the project. But right from the get-go, we're dealing with modeling. We're modeling from the start. And then we develop the same models through the process, and ultimately the models never change, they never change hands, they sort of, it's the one and same model really that sort of moves with the chain of the processes and ultimately becomes what we build, or actually before that, ultimately becomes what we spit out to manufacture and then forms the basis for our assembly drawings, for example, and then and installation and all of that. So from the very get-go, actually, the DfMA mindset is embedded into our workflow. And we continue to invest heavily in this area because we sort of started ahead in this area and we're quite keen to stay ahead in this area. And ultimately, this is all what we're here for, trying to deliver buildings a bit more efficiently and as part of the process. So as I said, I'm going to use 2 case studies to illustrate my point. The first one is High Point Terrace. It's a multi-story residential building that we delivered many years ago. I believe it was 2017. It was a residential building in Elephant and Castle. I'll show you that. And then I'll show you something a bit softer in the way of how DfMA can actually overlay onto quite a nice crafted a piece of architecture as well. So these two case studies will be the projects that I will use to illustrate my points. So as I said, High Point Terrace is a residential building in Elephant and Castle in London, 8-story building, pre-Grenfell. At the time, I think it was 115 social housing units for Peabody. And the architect was Roger Stirk, Harbour and Partners on this one. So we came in as specialist timber engineer, delivering this building for Mace, who were the main contractors at the time. As I said, 2017, it took us 18 weeks on site to fully install the superstructure with a gross internal floor area of about 8,000 square meters. So this project probably pushed our boundaries quite a lot in terms of what we could do and how we could best optimize our sort of workflow, really, in terms of delivering quite a high-rise, dense building. So as I said earlier, our workflow is very, at the very start, we're modeling cost data for estimating costs. So we set out when we receive inquiries in whatever shape or form, typically when they're developed to a minimum level of architecture or define what the architecture is defined to a certain extent, we're cost modeling. And as part of that process, we're beginning to make an assessment as to what thicknesses of material might look like, where we have a kind of mindset of, what this might cost as a project, but also what it would take for it to stand up in terms of rough engineering principles. The same model gets exported, our engineers use the same model. They establish a structural strategy. They determine overall stability ideas through FEM. They get a sense of the load that the building will be imposing on the substructure. We have a rough kind of load takedown plan. We go into element design to some degree, and deflection and serviceability. But again, same model gets fed into the FEM model. And then beyond that, if we're going to kind of take the building further, this is looking around stage 4 now, 3/4. We go from concept model to sort of a coordination model where we really begin to overlay the architecture onto the structure, onto the superstructure, and then it becomes a back and forth coordination exercise between all the various disciplines, M&E, architecture, whatever else, facade design, all of these things basically get overlaid into kind of a coordination process. Again, the same model forming the basis of how we investigate. At this point in time, usually we have our eye on manufacture or our eye on site and possibility of actually delivering the building at certain timescales and as best as possible. Therein, we start to bring in the concepts around program and logistics. And again, the same model sort of feeds our logistical planning. It feeds our understanding of how the building might be accessed. All the kind of logistical conversations come in, and our construction management team, although they might have had sight of it at sort of cost stage initially to try and establish rough parameters, at this stage, this is where their bit of work gets a bit heavier, because now we've got our eye on build. We're beyond design. Design is pretty much near enough frozen. We're just finalizing, fine-tuning the details, really. So And then very quickly beyond that, we go from same model, really, and then we sort of start to think about how the model might be chopped up into panels that fit onto backs of lorries that get delivered to site at said time in said sequence, or whatever sequence is determined. And that basically, it begins the kind of a view, a very close view onto buildability matters very closely. So we're chopping up the model at this stage, and we're fragmenting it into lorry-friendly packs and panels, of course, with the engineering parameters in mind and ensuring that actually ultimately building stands up. So as I said, at this point in time, we've got our eye on lorries. We're looking at lorry loads, how the lorries might be stacked, that sort of thing. And then, we're looking at the intricacies of, how the panels come together. This drawing on the bottom left here is an example of one of our what we call construction assembly drawings. So at this stage, we're simulating what it might look like. And I think you can probably see a very sort of thumpy video on the right-hand side, sort of indicating what we're planning at this stage, and an understanding of, how the build process will actually work, really. So at this point in time, we're pretty much set in terms of understanding sequence and buildability. So it's fully established at this stage. In this project in particular, you see some pods sort of showing themselves up, popping up. On this particular one, we had to install some toilet pods in the process that were craned into place whilst we were also assembling our buildings. So that was all considered as part of a buildability exercise, really, on this one. And this is it basically in progress. So the real version of the simulated video you saw, and this was a live cam on site, essentially simulating or showing again what we had simulated was going to happen on site very closely. I mentioned earlier that we had some toilet pods, so some considerations around assembly and pre-lining of CLT elements also happened on this one, where actually to preempt any kind of health and safety matters, we opted to pre-line lift shafts and stair shafts and that sort of thing, just to eliminate any kind of health and safety consideration in terms of access into higher rise areas, minimize sort of scaffolding access in lift shafts, that sort of thing. So these panels were pre-lined in the factory and conceived in that sense and delivered to the site on the back of lorries in that way as well. I mentioned that DfMA sort of underpins everything that we do, and ultimately with the whole golden thread strategy and the government aspirations and sort of what the rhetoric in the industry at the moment is that ultimately this mindset, the built asset, is also quite important. And the record of the built asset, this facilitates our ability to, the movement from design to a record set, or as an asset set of information, is a very smooth transition generally. And this is a kind of real versus modeled scenario of illustration of that concept. So this transition is very, very easy for us. It's effortless in terms of the fact that the record information is pretty much there or thereabouts as we sort of complete the project, really. So that's one example of here, the key really high-rise residential development in a inner city London site. Optimization was everything, efficiency was everything, access to the site, the sheer amount of lorries that we had to get to site was significantly minimized because, obviously it's mass timber, but equally, it's sort of the onus on the implication on logistics, the pressure on logistics was quite a lot more minimized because of it was mass timber, as we were sharing really access routes with a significantly higher building adjacent to us at the time. So this made sense in lots of ways that this was delivered in this way, and the intrinsic planning and effort that went into optimizing this building paid dividends really in the end. So as I said, that's one way of one benefit that we've sort of honed on in terms of intrinsically having DfMA at our heart and our core. We're able to deliver buildings like that with a degree of efficiency by virtue of the needs of the project, really. Yeah, the other project I'm going to go look at is Modeling College. I don't want to sort of present kind of this modern method of assembly as something that actually potentially is quite sterile, or is good at kind of delivering sterile buildings or kind of predictive, repetitive structures, for example. Modeling College is an example of how DfMA lends itself to, small, large, and actually quite unique buildings and crafted buildings, really, particularly when there's a very nuanced approach required in terms of various bits coming together from the design point of view, but also from a craft point of view. Modeling College was what we call a highly crafted building, but actually DfMA served it quite well. So this is Modeling College. Some of you would be aware of it. It's quite a worthy Sterling Prize winner, really, on this one. And the project really came to us by one of our trusted supply chain partners. It's a testament, I guess, to, again, our understood expertise in timber design. But, they came to us specifically, an international supply chain partner came to us and asked us to help them deliver this building because of our local intelligence, and also with regards to things around site logistics. They didn't necessarily know much about because they didn't quite simply have that local intelligence. So this is a 3-story building. It's located in the grounds of the college, and the rest of the college sort of outgrew an old library building, which is about 300 years old. It's modeling in Cambridge. And, so a new space really was commissioned to house an extension to the library, and it required a response that was really sensitive to the historic context, but also, it called for quite a bold, visionary design fit for generations to come. Designed by Neil McLaughlin Architects. We think they succeeded really in creating a building that seamlessly fits into the context and is able to really launch the college into the future. There's the building. You'll be familiar with some of these images, but for us, the process was quite a nuanced one, and BIM and the ability to kind of model this in 4D was really quite integral to this process. One, from a sequence and installation point of view, the geometry constraints, they had to be harmonized really from a site logistics point of view, and from program and sequencing point of view, the efficiency just had to be there from the outset. And the main contractor were very, they were very sold, and they were very sort of, what's the one I'm looking for? They were very wedded to the idea of doing this in the best possible way. And I think they did a good job in terms of, they had a sort of keen vested interest in understanding the way that this could be best optimized in terms of delivery and sequence. And they worked really hard with us, as well as with the rest of the team as well. So we see how actually the DfMA mindset really fed us well in terms of sequence and installation on this one. But equally, a high degree of product, the intricacy of this project, the precision, really that we would say in retrospect could only really be made efficient and possible through the use of some of those tools that I looked at on the previous project. For this project, craftsmanship was at its core, really. As I said, it went as far as, the fact that a new brick range was created, handmade bricks were created for the project. And the supplier, our supply chain partner at Noy Holtzbau, NH, they went as far as creating an extra high visual timber grading for the project, really all in a bit to celebrate the craftsmanship or to express the craftsmanship. We needed to do 4 separate visits on this one. Again, coordination of all these separate visits and the sequencing was fundamental, and therefore the process served us well in helping us fine-tune those sort of different 4 visits. So it was one per level of building, essentially, because we're notching in and around other elements of structure. I've put some drawings in here just to kind of illustrate. Hope they're not very legible, but as I said, there was lots of coming together of elements. There are brick piers which supported sort of precast lintel elements. And these then in turn sort of carried the glulam beams, on top of which the CLT panels were positioned. This, again, this level of kind of intricacy could only be made possible by virtue of the workflow and the processes that we're sort of used to here at Eurban. Some details there again, just to kind of express, the strong, you don't really get a sense of the sense of materiality in here. I did talk about the handmade brick, the reconstituted stone, the concrete, the glulam, the CLT, the steel. There's lots of coming together of elements here. And therefore the coordination process was very thorough. There's timber to timber connections, there's timber connecting to steel, there's timber connecting to stone and masonry. So there was lots of interfacing between all these elements that came out of the modeling exercise and the kind of, with the view to manufacture sort of mindset that served us well on this project. I think I mentioned some steel. We have these steel shoe elements, which, you know, it's steel crafted, you could call it. There were 8 different variations of this arrangement of these steel shoes. And in the end, these steel shoes were sort of what carried those lovely lanterns that you see atop the building. You notice some slotted holes in there for the servicing as well. Again, all pre-coordinated as part of the process and predetermined, and you know, done in the factory, really, in the factory environment. Again, so that's it sort of in place. As I said, there's 8 different variations of this, and you know, all the way through to fabrication. Everybody was handling these elements in their mind's eye, basically, in a bit to kind of foresee what was going to be delivered to site. That's just an axo of the building, the brick piers carrying the brick cornerstone, the lintels, glulam beams, and then the CLT panels, and then you see how the lanterns very elegantly sit atop the building. So, you know, so that was one part of it. Beyond that, beyond the kind of drawing on paper modeling space, there was a lot of coordination required on the site side as well. As I said, we're there on 4 different visits, but we basically set up a makeshift factory on the site where these lanterns had to be pre-assembled. So you basically had a jig, you know, set up for 2 lanterns side by side, and then the roofers could, on the assembly of one of the lanterns, the roofers could come in and layer on the lantern, whilst we basically, this production line for the lanterns was basically happening on site. And then the lanterns were craned into place, pre-lined and pre-finished to quite a high degree, really. So again, this could only be conceived and with precision through a detailed sort of foresight of this process, and this is where you know, the DfMA mindset really sort of helped craft this building. So you'd see, as I said, mentioned the elegant lanterns. There are 12 lanterns, and then there was one tower crane shared between all the various trades spinning around at any given point in time. This is an aerial view of it, but I think this really sort of celebrates the kind of coming together of the different trades and everybody, you know, kind of pulling together in the same direction. You can sort of see where the makeshift the lantern factory is on site there, and then this was lifted into place as and when it was ready and adequately lined. There were 6, I think, timber lorries packaged in this one to suit the install sequence. But you know, the lorries typically will come and go, again, just in time, predetermined, pre-planned, and they would arrive, you know, as when they're needed, and material off the lorries would never really stick around for much longer than required. But you know, this required a significant amount of coordination on everybody's part, really. And I think it worked quite well, and the project really deserved to win the Sterling Prize. Some images, I think, from inside now. We can never get enough images of this building, to be honest. But you know, this is really, in our mind, a celebrate. I mean, a lot of the pictures you see in the media are kind of layered on in terms of finishes, so not everything is now lined, but you know, the structure also expresses itself in and around the finishes in the building, and you can see just how lovely the lanterns sit atop everything, really. So that's another way to do it, really, in terms of, you know, what DfMA can bring to architecture and craftsmanship, and it doesn't necessarily need to be seen as this sort of I don't want to use the word sterile, but sometimes we sort of think of it as a very kind of, you know, very methodical, almost kind of machined-like approach to delivering buildings, and that naturally lends a kind of itself some thoughts about, what these sorts of buildings might be. But again, I think this speaks for itself in terms of the quality of architecture that was delivered here, using the same tools really that serve us on buildings that are quite box standard. I think that's it really from me on this one. I guess it's just to say, we do this day in, day out. We get a mixed bag of projects. I did mention earlier that we've delivered something like 350 buildings in the UK, and we're delivering buildings in Asia and in Central Europe as well. But any shape, any size, our processes are generally the same irrespective of what we're delivering. And ultimately, we're constantly honing our processes because they are the making of us, really. We started out like this as a business, and in the end, we intend to stay ahead with this as a business. And I think the industry needs it really to get to hit some of those targets that we're all throwing around. So that's it from me, really. If anybody had any specific questions around the 2 projects, I'm quite happy to take them. I hope there are at least a few. Otherwise, again, if you wanted to get in touch regarding any other projects or you have an interest generally in what we do, quite happy to be of assistance at any point in time. So thank you very much.
Yeah, we've not had anything in the chat, but if anyone's got any questions, feel free to just unmute yourself and ask. Or take it that your presentation was extremely detailed and everyone got exactly what they wanted out of it.
That'd be great. Right.
We've had a thank you from Bella. Is that Sandy? Have you got something to ask?
I wonder how much do you actually gets manufactured here in Britain before it's assembled, or is it? Yeah.
Generally none at the moment.
Yeah.
The UK just doesn't have the forest cover at the moment. We don't have any production facilities in the UK yet sort of manufacturing CLT at scale. There is some ambition to produce CLT in parts of Scotland, for example. The forest cover is incomparable to Central Europe, which is where we generally source most of the material from. So our supply chain partners are in Austria, Germany, France, places like that. Austria, that area is quite dense in terms of where we get our material from. We've got partners in Germany as well, as I said.
So you design it, you decide what thickness and sizes and everything, and then you go out.
And we go to market to source the best product for the project. Some projects require box standard sort of spruce CLT panels, for example. That's bread and butter for us. But also we find ourselves delivering some quite bespoke solutions sometimes. Oak glulams are visible in Magdalen College project, for example. Accoya, one of our projects recently today or at the weekend learned that one of our projects was an RIBA Building of the Year award winner. That one had some Accoya columns exposed externally. So we sourced the right product for the right project and scenario, really. And because we're not tied to any manufacturers necessarily, it allows us to independently, selectively choose the best product for the project.
And are there a lot of, is it grown? Have you got more people you can go to now than say 10 years ago? Or
there's a few new players on the market. There's a few new players on the market. We've got some quite very established players, but there are a few new players on the market, which again, we're open to opportunities. We're trying out, all the time new suppliers, again, with the degree of, not caution, but with a degree of, thought as to how we select the material for the project. But there are some new players on the market, and we hope to see a few more, really. And generally, we're looking forward to seeing more to come out the UK, really, if possible.
And what about size of project? I mean, I specialise in extensions and house alterations and stuff. So, if you're just wanting to add something very small onto a house, is there a size where you go, do you know what, it's just not worth it?
We try not to turn anything away, but we generally advise people who come to us with anything less than 100 square meter worth of project that actually they won't get much value out of building in this way. Product and the outcome will be beautiful, But when you put into consideration the fact that the material is coming off on the back of articulated lorries from Central Europe, I think in terms of economy of scale, they won't get the best out of it. And that's, but generally we have done quite small buildings interventions, but the efficiency and the economy is in the volume of the timber.
Yeah. Once you've shown the project, you've shown the idea of the material enough to people in small projects to go, actually, it's not really,
It could be. It might be so special and unique in its kind of needs of material that actually, but it won't be a box standard extension, and it won't be priced as such, basically.
Excellent. Thank you very much, Sandy. Does anyone? Oh, we've got something in the chat. So for an external wall, say to Passive House standard, if the structure and walls are CLT, how much more external insulation would be required? In other words, what is the lambda of CLT? Where is the insulation positioned? And what is the external finish rain screen?
That is quite a technical question. I did know the lambda of CLT off by heart. Now I don't know. I've forgotten it. I've not had to register it for a while. Having said that, CLT is very thermally efficient, is what I can say. You also get, in terms of passive house standards, you also get a very sort of airtight envelope, because if you imagine that the panels in themselves are, they're airtight. So each panel is airtight, and then they're lapped together and joined in a way that actually you then have to only worry about the joints in the panel. And because these are sort of not tongue and groove, they're half lapped is what we call them. There's an inherent airtightness quality on top of which we then tape externally as well, where it's not a visual finished building. And sometimes we tape both sides on some of the passive house projects that were delivered. So it's very airtight in that sense. You don't need more insulation. If anything, you probably need less. What needs, obviously consideration needs to be put into, you need to consider sort of where your dew point sits in your kind of envelope assembly, because you're working with a slightly warmer material. But really, there's lots of guidance out there in the industry about how to best layer a mass timber building. But you certainly won't be needing to super insulate beyond what you would normally do.
Excellent. Any other questions?
I could find out the lambda value, and if that person leaves their contact details, I'm quite happy to answer that question directly once I remember what it is.
I'm sure we can pass it on if you send it over to us.
Yes, please.
Anyone else got any comments or questions or anything they'd like to say? Oh, Debbie has put something in. As you have been involved with our ASBP mass timber insurance playbook, can you let us know if DMFA is helpful for getting insurance?
If the what? MFA? Oh, the
DMFA, yeah.
Oh, it's if DfMA is DfMA is the process wheel. I don't think DfMA, I think the two things are kind of, no, not necessarily. I don't think there's no particular correlation between assurability or insurability in the process, as far as we see it, that would enhance, insurance prospects. What the process might do, and where it might offer more confidence, is actually inherently there's a bit of insight quite early on in terms of what you're going to get as a product, and therefore that can be presented to insurers quite early potentially, and an early engagement of insurers in the process of design and design assurance and quality can potentially actually make offer a bit of confidence in the direction of obtaining insurance.
Thank you.
Excellent. Any more questions? Anyone would like to unmute and ask anything, or anything going into the chat? Oh, that's something from Margaret. Thanks, fascinating talk. Hoping to see Magdalen Library soon. We are in Cambridge and we'll look up the lambda of the CLT.
Super. So that was you who wanted the lambda value for the CLT form.
Yeah.
No, thank you very much. Thank you.
Excellent. Okay. Any more for any more? Speak now or forever hold your peace. Oh, yeah. Do you think there is more of a market for mass timber in Switzerland and Europe, and more generally compared to the UK?
Yes, simply because they've been doing this long before we have. You know, it's a much more tried and tested and trusted way of building in parts of Central Europe and Switzerland and places like that. Yeah, I wouldn't say, you know, they've just been doing it longer than we have, and therefore the level of confidence is greater. This is not to say the backlash from the Grenfells and, you know, the risks around building in this way don't inherently filter in and around across markets, but, you know, there's more confidence really in this way. They've been doing it for longer than we have.
Excellent. They say thank you for that. Okay. I haven't seen any more questions come in. No one's, I think, rushing to ask any more. So I'll take that as everyone's happy and satisfied that they got what they wanted from the talk. So yeah, just want to say thank you so much everyone for joining us. It's been a really great evening. Enjoy the rest of your evening. Obviously, we will be sending out, as I said, the presentation, a copy of the talk and the chat transcript in an email to you this week. And just to say, coming up, starting this week, we've got a fantastic new series. It's our building services series starting on Thursday. So it's 5 parts. You can book individually or book into all of the whole series, but it's going to be a really, really great series. So do consider joining us for that. And we've got plenty of other really great events and training coming up. If you take a look at our website, greenregister.org.uk, and look in the training and events section. But other than that, thank you so much, Adedayo. It's been really great this evening. Thank you everyone for joining us and asking your questions and everything like that. And enjoy the rest of your evenings. Thank you.
Thank you for having me. Bye-bye, everyone.